Have you ever looked up at the sky and wondered, what if, in the blink of an eye, our sun vanished, and in its place a completely different star from a far-off, unknown universe appeared? Imagine waking up not to the familiar warm glow of our yellow sun, but to the fierce blue-white glare of a supergiant, or perhaps the dim red glimmer of a tiny dwarf star. This isn't just a fun thought experiment, it's a journey into the heart of what makes our world, our home, possible. The universe is filled with countless stars, each with its own story. Swapping ours would rewrite our story completely, from the first page to the last. Our connection to the sun is the most fundamental relationship we have. It's more than just a bright light in the sky, it is the engine of our world. Think about it. The sun's gravity is the invisible hand that holds Earth in its perfect orbit, preventing us from spinning off into the cold, dark emptiness of space. It's a cosmic dance, and the sun is our partner, leading us through the seasons year after year. So what would happen if this cosmic engine was suddenly replaced? The consequences would be immediate and catastrophic, or perhaps just deeply, deeply strange. We are about to explore this cosmic swap. Let's journey to alternate realities where Earth orbits a new alien sun. Prepare yourself. The universe is about to get very, very different. Our sun is a star. A very special star, at least to us. It's classified as a yellow dwarf. It might sound small, but it's the perfect size for us. Burning steadily for about 4.6 billion years, with enough fuel to keep going for another 5 billion. This stability is key. It's like having a perfectly reliable furnace for our entire planet. It doesn't burn too hot, it doesn't burn too cold. This consistency has allowed life on Earth to evolve over millions of years, adapting to a predictable cycle of day, night, and the gentle rhythm of the seasons. Our sun is, in a word, dependable. The sun works through nuclear fusion. Deep in its core, pressure and temperature are immense. Hydrogen atoms squeeze together into helium. That releases an incredible amount of energy. Energy travels from core to surface, then radiates into space as light and heat. This is sunlight. Every second the sun converts millions of tons of matter into energy, a gigantic natural nuclear reactor at the center of our solar system, providing the power for everything we know and are. This solar energy does more than give light and warmth, it drives our planet's systems. Heat evaporates water from the oceans, which forms clouds, which returns as rain, creating rivers and lakes. It powers wind across continents. Let's perform our cosmic swap. First, we replace our sun with a blue supergiant, a true monster of the cosmos like the star Rigel. These stars are dozens of times more massive than our sun, and can be hundreds of thousands of times brighter. The moment it appeared, our sky would be filled with a blinding blue-white light. The concept of day would become an assault on the senses. The sheer intensity of the light would be unlike anything we have ever experienced. It would be brighter than a welder's torch everywhere all at once. Night would offer no escape, as the new star's light would likely be bright enough to read by even on the dark side of the Earth. The heat would be even more devastating. A blue supergiant burns incredibly hot, emitting vast amounts of ultraviolet radiation. The temperature on Earth would skyrocket. Our oceans would begin to boil, sending massive clouds of steam into the atmosphere. This would create a runaway greenhouse effect, trapping even more heat. Within a very short time, the surface of our planet would become hotter than an oven. All life on the surface, plants, animals, and people, would be scorched away. Our green and blue world would be sterilized, transformed into a barren, rocky wasteland like Venus, but worse. And then there's the gravity. A star so much more massive than our sun would exert a much stronger gravitational pull. Earth would be yanked from its stable, nearly circular orbit. We would be pulled into a new, much closer and faster path around the stellar behemoth. Our year might shrink to just a few weeks or even days, but we wouldn't be around to experience it. The immense gravity could also create powerful tidal forces, stretching and squeezing our planet. This could trigger massive earthquakes and volcanic eruptions on a scale never before seen, tearing the planet's crust apart from the inside out. Now for a different swap. Let's replace our sun with a red dwarf, the most common type of star in the universe. Imagine a star like Proxima Centauri, our closest stellar neighbor. These stars are tiny, often less than half the size of our sun, and much, much dimmer. If one suddenly appeared where our sun used to be, our world would be plunged into a perpetual twilight. The sky would lose its bright blue color, replaced by a dim, reddish-orange glow. The new daylight would be no brighter than the light we see just after sunset on a clear evening. The world would become a place of shadows. The drop in heat would be immediate and severe. A red dwarf emits only a tiny fraction of the energy our sun does. Earth, at its current distance, would quickly freeze. The average temperature would plummet far below zero and a new ice age would begin, but one from which we would never recover. The oceans would freeze over, starting at the poles and spreading to the equator, entombing our planet in a global sheet of ice. But this creates a new problem: tidal locking. Our planet would become locked in its orbit. One side of Earth would permanently face the red dwarf, the other side would be frozen in eternal night and darkness. A thin strip of land between these two extremes, a twilight zone, might be the only place where liquid water could exist. What if we swapped our sun with something truly bizarre, something from the pages of science fiction? Imagine a pulsar taking its place. A pulsar is a type of neutron star, the super-dense, collapsed core of a massive star that exploded. A pulsar also spins rapidly, sometimes hundreds of times per second, sweeping beams of intense radiation across space like a cosmic lighthouse. Or consider a binary star system, where two stars orbit each other. Let's say our sun was replaced by a pair of suns. Let's push the boundaries even further. What if our new sun was a black hole of the same mass as our sun? Thinking about these scenarios reminds us of how incredibly fortunate we are. Our sun, our simple yellow dwarf, is the perfect star for us. It is the right size, the right temperature, and the right age. It provides the stability and energy that life needs to flourish. The universe is filled with countless stars, terrifying giants, dim dwarfs, and exotic cosmic wonders. We won a cosmic lottery. So, the next time you feel the warmth of the sun on your face, take a moment. Appreciate that steady, life-giving light in our sky. And perhaps just for fun, imagine what it would be like to look up and see a completely different sun shining down on you.